Okay, all are able to hear me, yeah?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Did ma'am lead the meeting?
Yes, ma'am left.
Hey, who is Abhinav Reddy? Hey, who's Abhinav Reddy? Telugu gang, do you know?
Abhinala.
Abhinav Reddy.
He's from
Ma'am,
another section, I think.
Abhinav is
that
from
even
another
I
section.
know. Which one of
Yeah.
you? Which one of you gave the paper to him? Which one of you gave the paper to him?
Who's that imposter?
Ayo, ayo. It's fine. It's fine. Let's talk in the group because this is getting recorded also. We'll talk in the group. But what made you think that will be the same paper? Ayo. This is
He,
so fun.
he submitted in our group. In
Yeah,
our
I guess so. That's what he did. He submitting is fine. He didn't know that. But who gave him the link for our test paper? Guys, if you want to give the papers, take screenshot. Don't do all this. Hey, it's getting recorded. Huh? Hey, who's recording?
Rahul, you are being recorded.
I know, I know. Stop recording.
Bro, ma'am recorded.
Oh, shit. Oh, it's going to ma'am. But whatever you guys did is very wrong.
Okay, we'll begin the class for today. Are you able to hear me?
Yes, ma'am.
Yes, ma'am.
Okay, so we will finish the left out topics in unit 2. Okay, so we have already learnt in our last class the different characteristics of a DC motor. So what are the various characteristics that we have discussed for the DC motor? Just refresh the things now. Regarding characteristics of DC motor, what are the various characteristics of DC motor? Come on
Torque
the
and
top.
armature current, speed and armature current.
Yes, for all the motors, we discussed the three characteristics, that is how to draw torque versus armature current, then speed versus torque
Speed and
characteristics, then
speed and
torque
armature
versus
current.
armature current. Okay, these three characteristics we discussed for all the three motors. What are the three motors? Series, shunt, compound motors. We have discussed how to draw the characteristic curves. And then we discussed the different types of single phase induction motor in the last class. So like that, we have to discuss the nature of the characteristics of DC generators also. So you know how to classify a DC generator. So how will you be classifying a DC generator in general? DC generator classification. How will you do? DC generator. How will you classify DC generators? Come on, how will you classify DC generators? Some answer should come from your side, or otherwise I will handpick people to give me answer for my question. If you are not answering, I will give punishment for you. Better you respond from your side without me asking.
Separately
What are the
excited,
various types? Self-excited
self-excited,
and
Separately.
Self-excited and separately. Under self, what are the various classifications that you are having?
Series, shunt, compound.
Series, shunt, and compound. Okay. So for all these generators, you need to discuss how to draw the characteristic features. Okay, that we are going to talk about today, plus the starters for the DC motors. These two things we'll try to finish it off. Now the characteristics are listed out here. Okay, for a DC generator. So what are the two characteristics that you are having? It is there in the slide. Just can't you look and tell the answer? What are the characteristics for a
Open
generator that you are having?
characteristic. Load
Open circuit characteristics. This is also called as no load characteristics. Okay, open circuit characteristics is also called as no load characteristics, and that is drawn between the open circuit voltage and the field current. And the remaining characteristics will be drawn with load on the output side, and under the load characteristics you are having two classifications. What are the two characteristics that are coming under load characteristics? Come on, Roshan will give me the answer. What are the two load characteristics that are listed in the slide? Roshan, Aryan, Ayush. Between you three, I want the answer.
Internal and external.
Internal and external characteristics. So internal characteristics is drawn between what parameter? Internal characteristics, as you can see, it is drawn between what parameter? Again, Roshan and Aryan. It is drawn between what parameter? Internal characteristics. Aditya Raj, Aryan, tell me the answer. Internal characteristics is drawn between what characteristics, man? Aditya Rajan Agarwal. Come on, people, if you are not even trying to give me the answer, you will be given sure punishment. Okay, otherwise I won't be able to get anything from your side. I don't want to be remaining silent. Come on, internal characteristics is drawn between what parameter?
Ma'am, can we also give the answer?
Yes, others also can give.
IA and EG.
Ma'am, current and potential.
IA and EG, that is generated EMF, and external characteristics is drawn between the load voltage and the load current. Okay, so this is how you will be drawing the characteristics of a generator. Now we will see to how the characteristics will be drawn. Okay, generally I told you there are two characteristics. One that is drawn at a no load condition, that is called as open circuit characteristics. The second characteristics will be drawn with the load, and it is classified into two categories, external and internal characteristics. Okay, now we are going to see about open circuit characteristics, otherwise called as, what are the different names that are given to it? Roshan, Aryan and all, I am going to mark absent. What are the characteristics?
No load.
Open circuit characteristics, otherwise called as no load characteristics and magnetization characteristics. And as I have already told you, it will be drawn between the field current IF and it will be drawn between the open circuit voltage. Now, as you can see, the characteristics nature, how does it vary? And this will be conducted, this testing will be conducted with load or without load. If you want to draw the open circuit characteristics, will you have the load connected at the output side, or you are going to open the output side?
Ma'am, load will be connected.
No load.
No load.
No load. No load.
No load. Okay, you are going to remove the load connected. Okay, you are going to remove the load that is connected at the output side. You are going to open the output end. Alright, and you are going to vary the field current. Okay, you are going to vary the field current and you are going to observe what nature of variation takes place at the output side. You are going to note down what is the open circuit voltage, and you are going to draw a curve between this voltage and the field current. So as you are observing from the nature of the curve, it is showing three three degrees of variation. First thing is this one, and the second nature is a linear variation, and after that it gets saturated. Okay, initially here at this point, what is the value of IF at here? IF.
0.
At this particular point, what is IF? 1.
Yes, ma'am.
IF is 0, ma'am.
0. Okay, no field current is given at this particular point, but what about EG? Is there any EMF or no EMF is present?
EMF is present.
EMF is present. So that EMF is called as what EMF? That EMF is called as what EMF? There is a name given for that name. EMF, isn't it? What is EMF? Residual EMF due to residual flux. You know what is residual magnetism property? That we have studied in this same unit under magnetization. So what is residual magnetism property? Even if you remove the H, still there will be some small amount of flux density present, even if you remove the magnetic property. So that property is called as residual magnetism, because of which a small amount of EMF will be induced in the system. So that EMF is called as what EMF? What is the name of that EMF between 0 and none? That is called as residual EMF or residual voltage. At that point, IF is equal to 0. Next, it slightly curves. Okay, it slightly curves between 1 and 2. It slightly curves. Okay, you can see here between 1 and 2, it slightly curves. And then between 2 and 3, what is the nature of the curve? Between 2 and 3, what is the nature of the curve?
Linear.
Linear. That is because whenever you are making some variation in IF, same variation you will observe in the EMF also. So in between you will be having a linear nature of variation. Then after 3, it again becomes non-linear. It curves a little bit. That is because of what property? What property? Beyond 4. After this particular point, what happens?
Saturation.
Saturation. Because of that saturation property, still if you make an increase in IF, there won't be any increase in EG. It will remain constant. This is because of the saturation property. So this is how the characteristics that is called as, what is the name of the characteristics that you are observing here?
Open circuit.
Open circuit characteristics, otherwise called as no load characteristics or magnetization characteristics, drawn between what parameter? This characteristic curve is drawn between the field current IF and the generated EMF. And in order to obtain the characteristics, you need to keep the output side open. You need to remove the load, and you are going to vary IF value, and you are going to observe whatever variations you are observing in the output voltage. Okay, under open circuit conditions. And if you draw a curve, the curve will be looking like this. Initially, when IF is equal to 0, there will be some small amount of EMF. That EMF is called as residual EMF, and after which the curve will start slightly to curve and it will be becoming linear. But after 4, the IF variation will not give same variation of EG. Now the thing will be saturated and it will be constant curve. Okay, so this is open circuit characteristics that you are going to get for what type of generators? This will be the nature of the curve that will be obtaining for what type of generator? That is given in the title now. Separately excited DC generator and DC shunt generator. Both will have the same characteristics. Now, apart from this OCC, you are having another set of characteristic curves. What are the other set of characteristic curves? What are the other set of characteristic curves? This is drawn under no load condition. 2 more characteristics will be drawn under load condition. What is the name of the characteristics?
Internal and external.
Internal and external. Okay, so you can see for yourself This curve is called as the load characteristics. Okay, these are called as load characteristics. They are subdivided into two types, external characteristics and internal characteristics. Okay, external characteristics and internal characteristics, and these are conducted with load on the output side. Okay, and external characteristics is drawn between what parameter? As I already told you, external is drawn between VL and IL. Internal is drawn between armature current and the generated EMF. Okay, so this first curve that shows your rated voltage. Okay, you are going to run the machine so that it reaches the rated speed. Okay, you are going to run the generator at rated speed. Suppose if you consider the machine is rated at 1500 RPM, slowly you will push the speed of the machine to be at 1500 RPM and you will note down what is the rated voltage. That rated voltage is given by EG. Okay, under load conditions. Then you will be varying the load slowly, and there will be some small amount of losses that are happening. Two sets of losses will happen here. The first loss is happening because of what reaction? It is specified in the characteristics. There is some drop due to what effect?
Armature reaction.
Armature reaction. So there are two effects of armature reaction. I have told you in the earlier class, last class, that you are having a demagnetizing effect and cross magnetizing effect. Because of it, there will be some small drop when compared to the rated value of voltage. If you include that drop, if you eliminate that drop, then the voltage will become E. Okay, and if you are drawing E versus armature current, that characteristics will be called as, this characteristics will be called as what characteristics? It is having a small droop. Because of the effect of armature reaction, you are considering that droop. And what is the name of the characteristics? What is the name of the characteristics? Internal characteristics. Next, from that E, if you still consider one more drop of voltage because of RA, RA is armature resistance. So whenever you are having resistance in the circuit, you will be having some voltage drop. That voltage drop is IA RA drop. If you subtract that IA RA drop from E, then you will be getting V. And if you are drawing a curve between V and the load current, that characteristics will also be a drooping one, and that is called as what characteristics? External characteristics. Okay, that's all. Here, this straight line indicates the rated voltage. EG. EG is the rated voltage. From that, you are subtracting the armature reaction drop. The resultant will be E. If you are drawing E versus IA, that characteristics will be called as internal. And from E, if you are still minusing IA RA drop, then you will be getting VL. If you are drawing VL IL curve, that is called as external characteristics. Okay, that's all. Understood? What are internal and external characteristics? Both these characteristics will be drawn with or without load.
With load.
With the load. Okay, so summarize the factor. What are the three characteristics for a generator that you are having? One is drawn without load, that is called as no load or OCC characteristics, that is drawn between IF and EGO, that is under open load conditions. Next, you are to draw load characteristics. Load characteristics means you will have the load and you will run the machine at rated speed, rated voltage. That rated voltage is EG. And if you are varying the load afterwards, there will be two sets of drops. If you are considering the drop due to armature reaction, then the curve will be slightly drooping. This curve is called as internal characteristics. And still from that internal characteristics, if you are subtracting IA RA drop, then you will be getting external characteristics. That's all. Both are drooping in nature. Understood?
Yes, ma'am.
Okay. Next. We have discussed how to draw the characteristics for a separately excited and shunt. Okay, now how the characteristics will be obtained for series generator is the question. So this curve shows load characteristics for OCC will be similar. Okay, shape of OCC for series, shunt and separately all will be similar. So you can write the same theory and same characteristics you can draw for all the generators. But when it comes to load characteristics, it is having a what type of characteristic? As you can observe, this is your rated voltage curve. Okay, from which if you are subtracting the armature reaction drop, then you will be getting the second curve. That curve is called as what characteristics? All the three are load characteristics. Okay, this picture is showing load characteristics. So what is the center characteristics? Curve number 2 corresponds to what characteristics? It is drawn between E versus IA. So what characteristics does it represent?
Internal.
Internal. Okay, curve. This one is internal characteristics. Okay, from the internal characteristics, still you are going to subtract one more drop. What drop are you going to subtract now? Here you are going to subtract one more drop. That is IA RA drop you are going to subtract. Then you will be getting the curve number 1. That curve number 1 is drawn between V and IL. That is called as what characteristics? That is called as external characteristics. Okay. And all the characteristics, as you can see, is racing characteristics or what nature? All are representing racing characteristics or constant somewhat. All are representing what characteristics? If you can see, this is racing, this is also racing, this is also racing. So all the characteristics are called as racing characteristics. Okay. And not only RA drop will be considered here, here you have to consider RSC drop also, because both field and armature are connected in series. IA, RA plus RSC drop you will be considering here. Okay, so this is rising characteristics, but for the other generators it will be a constant drooping characteristics. Okay. So these are all about the characteristic features of the three generators, shunt, series and separately excited. Already I have told you what is armature reaction, what are the two effects. It demagnetizes and cross magnetizes. Demagnetizing means it will weaken the main flux. Cross magnetizing means it will distort it. Okay, and I told you demagnetization, weakening of the main flux means it will reduce the generated EMF. And it will be resulting in sparking at the brushes. Okay, this might be asked in 2 more questions. And already we have discussed power stages of motor. Now we are going to discuss the same for a generator. For a generator, what type of energy conversion happens actually? You tell me. What energy conversion happens for a generator?
Mechanical into electrical.
Mechanical to electrical. So what input is given here for a generator?
Mechanical.
Mechanical input. Okay. Then what losses will happen afterwards? Mechanical input means rotation. Whenever rotation is involved, what are the losses that will happen? I've already taught you what are the various losses. You are having copper losses, you are having magnetic losses, you are having rotational losses. So what losses will happen? Iron, and here this will be indicating magnetic losses, that is eddy current loss, then hysteresis loss, friction loss, everything will happen here. So if you subtract the losses from the mechanical input, you will be getting what power developed in the armature? Electrical power, that is given by equation E into IA. After which another set of losses will happen because of the armature winding and the field winding. What is the name of the loss?
Copper loss.
Copper loss. And if you subtract that copper loss from E into IA, you will be getting finally the electrical power output at the shaft, that is given by the formula V into I. So this is power stages for a generator, how the energy conversion happens for a generator. Alright. Next, we will move on to what is the purpose of a starter and what are the different types of starter for the DC machine. Okay. Now already I have told you what is speed equation. What is speed equation that you are having? speed equation. There are various equations for a DC machine. EMF equation is there, torque equation is there, speed equation is there,
Ma'am, N directly
voltage equation is
to
there.
EB flux.
N is proportional to EB divided by phi. N is proportional to V minus IA RA divided by phi. That is the equation, isn't it? Okay. That is speed equation. Now, if you consider this is IA is equal to V by RA. Generally, the equation will be IA is equal to V EB divided by RA. Okay, because voltage equation will be EB plus IARA. This is your voltage equation that you are having for the machine, I think for a motor. Okay, this will be the voltage equation. Just I am rewriting this equation for obtaining IA, so it will be EV minus EB divided by RA. Okay, by simple mathematical manipulation, the armature current is given by this formula V minus EB divided by RA. But assume, suppose if the machine you are directly connecting to the supply, okay, DC supply if you are giving directly to the machine, then initially will there be any back EMF or no back EMF? Initially, starting condition, there will not be any back EMF. So this will be 0. So IA will be simply equivalent to V divided by RA. So because of this particular reason, the armature resistance will also be very small. So what will happen to the current? Both are related in what manner? IA and RA. IA is the armature current, RA is the armature resistance. If you are having a very small value of armature resistance, then what will happen to the armature current? Initially there is no back EMF, so it cannot says it is, if it is low means both are inversely proportional, so the current that is drawn from the supply will be very huge. Okay, about 17 times full load current will be drawn. Okay, you can see here how much time of current is drawn here. 25 to 30 times of full load current of motor will be drawn. Suppose if the rated value is 5 ampere, then 5 into 25 is how much? I think around 200 300 times 300 ampere current will flow. So if such a heavy amount of current is allowed to flow through the motor, what will happen to the motor? It is rated at 5 ampere, but it is now drawing 25 times 5 ampere current. So what will happen to the motor if it is allowed to circulate that much amount of high current? General knowledge question. Again, do you want me to find out somebody and ask question? That is better. Come on, Chinmoy, Dhruv and Srish, tell me what will happen to the current. Initially, I told you the current IA is given by the formula V minus IB divided by RA. But suppose if you are starting directly the motor from the supply, there will be no back EMF. RA will be very small. So IA will be very, very high, about 25 to 30 times high. So if the rated current is 5 ampere, originally it will be multiplied by 25. So how much current will flow and what will happen to the motor in this case?
125.
It will be high. So what will happen to the motor?
Ma'am, can we say?
Motor is actually having two windings, copper winding only. So if it is allowed this much current to flow into the winding, what will happen to the winding? Winding and all. Yes, winding and all will burn. Okay, so the motor will get damaged. Okay, motor will get damaged. So all this will happen if you are trying to connect directly the motor to the supply. Okay, if you are connecting the motor, this is your motor symbol already, you know the armature. This is your shunt field. If you are directly connecting the motor to the supply, this will be the case. But suppose if you are able to increase the value of RA somehow, okay, if you are able to increase the value of RA somehow by connecting some extra resistance in the form of RS, then what will happen to IA?
Decrease.
Decrease, ma'am.
It will decrease. Okay, that is why you need to have a starter. You cannot start the motor directly from the supply. You have to have a starter in between. So what is the necessity of a starter? That is an important question. Why do you need to have a starter?
To increase the resistance.
To increase, to add the starting resistance. During starting time alone, the extra resistance will be added, because of which what will be the advantage?
It will
What is
prevent
the
Damage.
from
you will be able to reduce the high inrush of current. Okay, high inrush of current will be reduced. Because of that purpose only you are using what mechanism?
Starter.
Starter.
Starter. Okay, understood the necessity of starter, everybody?
Yes, ma'am.
So will you be able to start the motor directly from the supply, or you need to have a starter?
We need to have starter.
Need to have a starter.
Yes, okay. And next we will move on to what are the different types of starter that you are having. Okay, there are three types of starter actually. One is your 2-point starter, that is used for series motor, and you are having 3-point starter, 4-point starter, and this can be used for shunt and compound. Okay, so this might be asked in your MCQ. So there are three types of starters actually. What are the three types of starter?
2-point, 3-point, 4-point.
4-point, 3-point and 2-point. For which machine you will use 2-point starter?
Series.
Series. 3-point and 4-point starter you are going to use for what machine?
Shunt and
Shunt
compound.
and compound.
Shunt and compound. Okay, this sort of question might be asked in MCQ, so you make a note. Okay. Now all the starters will not be asked. So for simplicity, we are going to discuss only about 3-point starter. So this is your 3-point starter. That is used for what machine again? It may be used for a shunt machine or it may be used for compound machine. But here, in particular, it is used for what machine? You can see the circuit diagram. This is your armature winding. This is your field winding. Both are connected in what manner? The field and armature winding. How are they connected?
Parallel.
Parallel. So what type of machine is that, or what type of motor is that?
Shunt.
Shunt. Okay, so this is your shunt motor. Okay, this is your shunt motor, for which what type of starter is used?
3 or 4
3
point.
point.
3-point starter. Okay, I will tell you why it is called as a 3-point starter. You can see here, there is an L, there is an Z, and there is an A. Okay, so how many points are there?
3.
3. That is why it is called as 3-point starter. Okay, and where does this L point go? L point is connected to what?
Positive.
Plus means line. Okay, so L represents line, that goes for line. And where does this A point go? A generally represents armature or field. A represents, this portion is representing armature or field.
Armature.
Armature. So this is going to armature. This is going to line. And remaining Z goes to where? Z represents what?
Field winding.
field. Okay, so these are the 3 points. That is why it is called as 3-point starter. And this is shown for a shunt machine. Suppose if it is a series machine, where the field will be? That is a question. Suppose consider this is a series machine. Okay, series machine. Then this field will not be here. It will be connected here. Yes or no? This will be a series winding. Okay, so in that case you don't need the extra point. So how many points will be there if it is a series machine?
2 point.
2 point. That's why what point starter is used for series motor?
2 point starter.
2-point starter.
Okay, so understood the difference, huh?
Yes, ma'am.
Understood the difference? Now one more thing, what are the two protective devices that are present in the circuit? There are two protective devices. You can see for yourselves this one, N is there, isn't it? That is called as no voltage release. Okay, no voltage release. That is protection device number 1. And another protective device is there in the starter in the form of this arrangement. So this arrangement is called as OLR, that is called as overload release. Okay, so what are the two protective devices that are present in the starter?
NVR and OCR.
NVR and OLR. What is NVR? NVR means
No
no voltage release.
Voltage release.
Overload release is otherwise called as OLR. So these are the two protected devices that will be present in almost all the type of starter. Now let us see to how it works. Okay, I told you that if you want to put a limit to the starting current, you have to add what in extra to the circuit, to the motor. I told you I want to limit IA. Okay, initial during starting condition. So I will be adding up extra amount of resistance to this armature resistance. Here you will be having armature resistance. To series with this armature resistance, I am going to add the extra resistance value, that is RS. So if I add the extra value of resistance, what will happen to the current?
Decrease.
It will reduce. So that is what I am going to do. Alright. So there is a handle. This one is my handle. H represents my handle. Alright. All the other elements will be present inside the box. Only the handle will be, knob will be present outside. So I will push it from off position. This is my off position. I will push it from off position and will bring it to this point. First stud. This is first stud, second stud, third, 4, 5, 6 stud. Okay. If I do this, it will get connected to the first stud. So the entire RS is connected in series with what?
Armature.
Armature. So here I am having RA. Here I am having RS. So extra resistance is thus added. So what will happen to the current?
Decrease, ma'am.
It will decrease. Okay. Started. Motor is started. Now it will develop EB. Back EMF will be developed. Now there is no necessity of the starting resistance still inside the system. So I will want to eliminate the presence of the starting resistance. So what I will do, I will push this handle to the second stud, I will push third stud, fourth, fifth, sixth stud, I will push. Now I will connect it to the last position, that is my on position. Okay. Now if I keep the handle at this position, what will be the resistance that is added? Is there any resistance added now at this particular point or no resistance?
No resistance.
No resistance. Okay, if I add the handle, if I push the handle and you connect it at the last stud, then the RS value is eliminated. Okay, so that is why it's called as on position. So now, as usual, I can run the machine. Okay, this is how a starter works. But still you need to know what is the use of this NVR and what is the use of this OLR. Suppose we assume power supply is turned off. Okay, power cut. Then what do you need to do? What should be the status of the starter? Power is cut. Okay, Mains are off. So the starter should be pushed to off position or it should be still in on position.
To off position.
It should be in off position. So the handle which is in on position, it should be deflected back to off position when power cut problem is there, when there is no voltage. So in order to achieve that, you can see that S no here, that S is nothing but a soft iron piece. And here this is nothing but a magnet. Okay, so when the starter is slowly pushed and if it is kept in on position, that soft iron piece will come here. And this will attract, both will attract each other. Okay, alright. Now that will be in on position. Suppose if you assume the power supply is cut, then what will happen to the magnetism property of this magnet? No power supply. So it will get demagnetized. So if it is getting demagnetized, what will happen to the attraction? Will there be any attraction still or it will repel?
No attraction.
Yes. Now the attachment between this soft iron piece to this NVR will not be there. So automatically the handle will come to off position. Okay. So that is how NVR protects. From what does it protect? No voltage release. What protection does it offer? When the power is cut, all of a sudden the starter should not be kept in on position. It should come back to off position. So in order to achieve that, what protection device is used?
NVR.
What is the expansion for NVR?
No voltage release.
No voltage release. Okay. Next, one more protection device is also there. The name is OLR, otherwise called as overload release. Suppose by chance from the supply, if there is a overload current, okay, then what will happen? This is also a soft iron piece. It will move up, okay, and will short these two terminals. Okay, it will short these two terminals and again this will be demagnetized and it will be deflecting the handle back to off position. That will happen under overload condition. Again the starter will be pushed back to off position. So this is the entire way in which a starter operates. This is common for all the types of starters. Only the number of terminal and the connection will be differing. All other things will be remaining the same. So you people understood the necessity of starter, the different types of starter, for what machines all the starter is used and how it operates. All these things have you understood or not for a starter?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. Okay, so with this all the DC machine topics are over. Now we will move on to generator and alternator, three-phase machines. Already we have discussed three-phase induction motor. What are the two types of three-phase induction motor? Last class we have discussed no three-phase induction motor, a synchronous machine. Depending upon the shape of the rotor, you are having the classification. What are the two types of rotor that you are having for a three-phase induction machine? Three-phase
Squirrel cage
induction
and
motor,
slip-ring.
squirrel cage and slip ring.
Slip ring.
Okay, and same thing we have discussed for single-phase induction motor also. Single-phase induction motor is self-starting or not self-starting?
Not self-starting.
Not self-starting. So you are going to temporarily convert it into a two-phase
Two-phase or
motor.
three-phase.
And how they are classified? Single-phase induction motor. One is permanent resistance,
And second split. Man.
split phase. Second one is capacitor start. Third one is, last one is capacitor start, capacitor run. Okay, all these things we have discussed in the last class. Now in the same fashion you have to discuss synchronous machines also. Synchronous machines are also doing generation or motoring. So you will be having synchronous alternator and synchronous motor. So first we will discuss synchronous alternator. Okay, synchronous generator, also called as alternator. Okay, this machine is used for power generation. I already told you in big thermal power plants, You want to have a bulk amount of power that is to be generated. For that case, what machine will you use?
Synchronous machine.
Synchronous generator. Okay, otherwise called as alternator. And alternators are two types. Like you are having squirrel cage and slip ring. Here also the rotor will be two types. I will show you the shape of the rotor. Okay, here you can see what are the two types of rotor that is indicated here. One is Salian pole, another one is, what is the other name?
Smooth cylindrical type.
Smooth cylindrical. Salian pole means here you will be having projected pole like this. So this is your rotor. Alright. So you can see for yourselves, this is projected, this is projected, this is projected, and this is projected, north, south, north, south. So this type of rotor is called as what type of rotor? Salient or projected pole rotor. The poles will be projecting out from the center axis. But on the other hand, if you are having a smooth cylinder, okay, and you are having like this. Like this you will be having. I am not drawing it properly, but the arrangement will be looking like this. In these slots you will be having conductors that are placed. So as you can see, this is smooth, okay, smooth. So this type of rotor will be called as what type of rotor?
Smooth cylindrical type.
Smooth cylindrical type. Okay, so what are the two types of rotor that is present in a synchronous generator? One is salient pole, other one is smooth cylindrical. Suppose if you want to select a particular type that is used for steam turbine or turbo alternator, what type you will be using?
Smooth cylindrical type.
Smooth cylindrical. But on the other hand, for IC engine and all, if you want to select an alternator, engine driven, okay, so if you want to use a alternator for IC engine and all, that is running at low and medium speed, okay, so what type of rotor you are going to offer?
Salient type.
Salient. Okay, low speed means what type again? This might be asked in MCQs. Low speed and medium speed means what type of rotor will you use? One more time.
Salient.
Salient. And what will happen to the diameter and length? These points are important, so I am telling these points again and again. Okay, suppose if you want to select an alternator to run at low and medium speed, salient pole you will select, and what will happen to the length? The length will be short and diameter will be large. Okay, because the speed's nature is very less. But on the other hand, if you want to select an alternator that is running at a very high speed, then what type of rotor will you select?
Smooth cylindrical type.
Smooth cylindrical. And if you see to the length will be large and the diameter will be less, because it is used at a very high speed, so you have to have a very small diameter and the length should be large. Okay, this is how you will be differentiating two types of rotor that is present for an alternator, otherwise called as a synchronous generator. One more time, what are the two types of rotor that you are having?
Salient pole type.
Salient and smooth cylindrical. Salient means low speed, diameter will be large, L will be short. Smooth cylindrical type is used for high speed, the length of the rotor will be large and the diameter will be less. Okay. Now we will see to how it operates. Working of an alternator we will discuss. Okay. And as usual, you will be having a stator. The inner portion of the stator, inner periphery, this is your stator core. Okay, stator core, inner periphery. Here you will be having RYB. Supply will be given, AC supply, and here you will be keeping the stator conductor. Okay, stator conductors will be placed like this. and you are going to connect this in star shape. All these will be connected in star shape and it will be given to AC supply. So what will be happening? The magnetic field will be set up. Okay. In this magnetic field, you are going to keep the rotor. Salient or non-salient, whichever may be the case, you are going to keep the rotor here. This is salient or non-salient, this type of rotor?
Salient.
This is salient. So you keep the rotor, you connect it to a shaft, you rotate. Okay, rotate the rotor in the magnetic field. So as per Faraday's law of electromagnetic induction, what will be induced?
EMF.
EMF will be induced. Okay, so what is the energy conversion that happens in an alternator? Mechanical to electrical or electrical to mechanical? Synchronous generator or alternator? Generator means always what energy conversion happens?
Mechanical to electrical.
Mechanical to electrical. Okay. So this is how synchronous alternator operates. One more important thing how to discuss, synchronous speed. Okay, synchronous speed is given by 120 F by P. Okay, synchronous speed. Always synchronous machines will be running only at one speed. It will never run at any other speed. What is the name of the speed? What is the name of the speed? That is why those machines are called as synchronous machines. They will be always running at what speed?
120. Synchronous.
Synchronous speed. Okay, the name is given to them because they will be running only at this speed. Okay, they cannot be run at any other speed. And what is the formula for the synchronous speed? Ns is called as your synchronous speed. So what is the formula for it? 120 F by P. F represents your frequency and P represents your number of poles. Okay, so this equation represents what speed?
Synchronous.
Synchronous speed.
Synchronous speed. One more question I'm asking you. Will you be able to operate the synchronous machines at any other speed other than synchronous speed?
No.
No.
No,
It's
ma'am.
not possible. Okay. So those machines will be always operating in one speed. It's called what speed? Sorry. What is the formula for the synchronous speed?
120 F by P.
120 F by P. Okay, this is regarding synchronous generator. Now, what will happen if it is operated like a synchronous motor? That comes the question. So again, you can see here, this portion is called as this portion is marked as NS and SS. So these are stator poles. Okay, this is your rotor. Alright. Now, rotor is like this. Here it is north, here it is south. So what will happen at this point? The working principle for a motor is electrical energy to mechanical. Okay. So you are going to give supply via the stator and you are going to set the rotor into rotation. Okay. Now observe this position. Here the pole is NS, here N, here SS and S. What will happen to the rotor? Repulsion or attraction? That is the question.
Repulsion.
Repulsion or attraction? Come on, like poles, what will it do?
Repel.
NS repel. Okay, so because of this repulsion, it is deflecting like this. Okay, repel. Okay, then it will repel and it will change its, one rotation it will again change its position. Okay, Let me see this. Okay. Again, if this is rotating in this direction, now both poles will be attracting and it will be running like this. Okay, once it will repel like this and it will run like this. It will oscillate. Okay, here and here, here and here, here and here, here and here, it will oscillate. But because of this oscillation, what will happen finally is the rotor will not be rotating at all. Okay, it will be remaining stationary only. So because of this particular reason only, the synchronous motor is not self-starting. Okay, synchronous motor is not self-starting. Why? Like single phase induction motor, synchronous motor is also not self-starting. Because of what particular reason? Come on, one time. Here it will be NS, here it will be SS, both will repel, it will come in this direction. Then one time it will rotate, okay, the stator pole will shift in position. Okay, now if it is shifting in position, it will come SS here, it will become NS here, and it will become N here, and here it will become S. So because of this, it will repel this direction. So it will repel one time here and one time here, one time here, one time here. So finally it will oscillate like a pendulum, it will oscillate, because of which it will not be rotating at all. It will not be set into rotation. Because of this particular reason only, is it self-starting or not self-starting?
Not self-starting.
Not self-starting. So what you need to do is, you are going to rotate the rotor. Okay, rotor should be rotated at a synchronous speed by some mechanism, and then you have to always have this position only. Okay, you have to make the rotor to come to a position where both poles are in attraction or repulsion.
Attraction.
Always is attraction. So if you are able to bring the rotor to such a position, then it will get attracted and the stator field will be rotating at a synchronous speed. So along with it, the rotor will also rotate. Okay, that is why you have to use some mechanism to bring the rotor to run at a synchronous speed, similar fashion to the stator field. Okay, and in order to have the starting methods, there are so many starting methods. What are the starting methods that are given here? So applications are also given. For power factor correction, it is mostly used, the synchronous motor. Okay, power factor correction, PFC. This might also be used, asked in MCQ. So whenever you want to use a machine for a power factor correction, then you will be preferring what machine? What machine is used for power factor correction? Synchronous? With this unit I will close. That's why I am trying to finish up fast. So what is the machine that is used for power factor correction and what are the various starting methods?
Synchronous.
Motor.
Synchronous
Okay.
motor.
And what are the various starting methods? You can use a DC motor, couple it to the shaft. You can make it run at synchronous speed. That is one method. Alright. You can use a field excitation. That is separate supply you can give to the rotor to make it come to synchronous speed condition. So these are starting methods and the different applications. Okay. With this unit number 2 is over. For your CT2, it will be unit number 2 and unit number 3. Unit 3 I will discuss in the next class. Before that, I want to discuss something. Okay, somebody is friends with this Abhinav Reddy, some brother of some sort, or who is friends with the Abhinav Reddy of F2 section? I wanted to clarify. Nobody knows Abhinav Reddy of F2 section?
No,
I am not angry on you or something. If you want that boy to get mark in CT, you have to answer me. If you are not answering me, then he will not get mark. He will get 0 only for CT. It all depends upon you. So who is brother of Abhinav Reddy or somebody who knows Abhinav Reddy? F2 section, Abhinav Reddy.
What happened, ma'am?
I don't know, somebody in your class passed out the link that I have given to him and he wrote test in my GCR. That is wrong. He is not belonging to my class. So some of the Telugu people, they shared the link. I wanted to know who. I am not telling that it is malpractice or something. Maybe you did not understand the way of testing procedure and you shared the link with him.
It might
Just
be
I
a
wanted
glitch
to
also.
know. Huh?
It can be a glitch also. Like this also happened with us in maths paper.
What ma? I am not understanding properly whatever you spoke.
In maths paper, it happened to us also.
I don't know, but I did not send the link to Abhinav Reddy. He does not belong to my class, but still he wrote test and his mark got entered into my GCR account. I don't know how.
Yes,
So
ma'am, in the
somebody must
max.
have shared the link that I have sent to
In
them.
maths, what happened? What happened in
Huh?
maths?
Ma'am,
ma'am,
in
First we
maths,
written exam in another
link
sir's GCR now.
of another
No,
source
no,
Another
no.
sir
GCR.
That
question
is
paper.
not
Who
what
who
happened.
wrote
In
in
ma'am,
Max?
they
Who
got
got
confused,
entered into
ma'am.
another person's
No,
GCR? What
ma'am.
is the
Sir,
No,
name of
no.
that
maximum
Nothing.
all of us got
Sir,
entered.
so we
That
have to
ma'am
again
sent.
write
That
down
sir sent the wrong
In
link.
maths, sir
And
sent
sir
the
said
wrong
again
link.
to return. Yes, ma'am.
Ma'am,
again we
in
have to
maths, what
written.
happened was the sir sent the wrong link, ma'am. That's what happened. Everyone wrote some other section paper.
But I did not send any link to Abhinav Reddy. He is not at all in my class.
Yes,
Some sort of mix up. How I will give link to him, I do not understand. The classes and all he is not attending, but test alone how he attends, I don't know.
Yes.
Because there are so many Telugu people here, I am assuming some of you shared the test link to him. That is how it got entered into my GCR. That might be the probable reason. So I wanted to clarify matters with you, or otherwise he will not get mark. Okay, that sir will put 0 for him if you are not telling me how that person got into my GCR. Again, I am calling out Telugu people. It all depends upon you. If you want that boy to get mark in his CT1, you are to open up and you have to tell me how he got the link. Otherwise, that sir will. What ma?
He's Abhinav Reddy, a Telugu guy.
Hey, Reddy does, so
Bro,
obviously
Reddy
Telugu.
means Telugu only now, bro.
Yeah, Abhinav Reddy. His name is Abhinav Reddy.
Ma'am, you can do
Okay.
one thing. You can send us the link for the test, and we will search in our WhatsApp for the link if someone has sent it to him.
Your voice is
So,
very low. I am not hearing out what you are telling
Ma'am,
me.
you
But you people did not have anything to do with it. Because that sir is asking me how that boy wrote in your GCR.
Ma'am, you can ask
So
that
I
boy,
can.
sir, ma'am. What is that boy saying? Abhinav
Yeah, I
Reddy.
will call. I will call. Okay, but I wanted to make sure that you do not have any hand in that. Because I
No,
am
No,
I
no,
because
no.
I will stand
No,
by
ma'am, we
you.
don't have.
Okay, all are sure of that?
ma'am,
Yes, ma'am.
before you call and talk to that
Yes,
boy,
ma'am.
check amongst ourselves, ma'am.
Yeah, I will
Because
ask,
otherwise he will
but
feel
I
bad.
don't know. Without you people sharing, he will never get the link. Okay, that is why the major doubt is I am having on you people, some Telugu person, newly joined probably. Okay, because he did not understand the confidentiality or something. Simply he passed on, or otherwise some people who were earlier in the class and now they are not here, they must have shared. I'm not sure, but some mistake must be done by you. Otherwise, this link will not be passed on to other section people. I am inviting you. How can that invitation be passed on to other section people who does not belong in my class? I don't know.
Yes, ma'am.
Because Abhinav Reddy is not my people. He is not in the invitation list. Okay, anyways, I will try to talk to that boy. If you have anything to do with it, you have to open up and you have to tell me. Okay? Otherwise, it is wrong on part of you. With this, I will wind up class now. Okay? All can leave.
Thank you, ma'am.
Thank you, ma'am.
Thank
Thank you,
you.
ma'am.
Okay, ma'am.
Thank you, ma'am.
Okay.
Thank you, ma'am.
Okay.
Hello,